Welcome, friends. In this lesson, your students are going to be looking at using addition properties to add. All right, our same standard, math, grade 3, number, sense, and operation, standard 2, add and subtract multi-digit whole numbers, build an understanding of multiplication and division operations. Same standard, the benchmark 2.1, add and subtract multi-digit whole numbers, including using a standard algorithm with procedural fluency, which we're going to get to. All right, so we have a problem like this that they'll open with, that Lily is organizing a book drive, and she collects books from the different places. From her school, she collects 27 books. From her library, 33 books. From her neighborhood, 10 books. How many books did Lily collect in total? So we're looking at 27 plus 33 plus 10. Well, the first method is group the add-ins in any way, and the sum will be the same. Now, of course, the add-ins are the numbers that we are adding together. So we could group 27 plus 33 plus 10, or we could group 33 and 10. So 27 and 33 would give us 60 plus 10 would give us 70. Where here we would have 27 plus 43, which, and again, they may choose to group it this way because they like adding the 10 first. They may choose to group it this way because 7 and 3 are friends of 10. Either way, we're still going to get 70. Now, this is the associative property of addition. It's not going to be important for students to be able to look at problems and recognize associative property of addition. They'll do that in later math courses. The important reason for doing this today is to get students comfortable with how they can move things around in addition problems to make the addition easier. Now, one thing, if you think your students might have problems with this, you could always start out in your bell ringers with something like some counters with just easy numbers. Like if I'm adding 2 plus 3 plus 1, 2 plus 3 plus 1. What happens if I add, we know the total is 6. What happens if I add 3 plus 1? That's 4. 4 plus 2 is 6. What happens if I add 2 plus 3? That's 5. 5 plus 1 is 6. I always like remembering associative property. What I used to tell my 7th graders is think of 3 people sitting beside each other at the lunchroom. And like if you're in the middle, maybe you're going to come associate with this person, or maybe you're going to come associate with this person. Order does not change. So that might be a fun way to start out the lesson, to just start with a very simple problem and some counters like this to show it doesn't matter which order I group those in, the sum is the same. Okay, now method 2 is you can switch the order of the add-ins and the sum will be the same. So we've got 27 plus 33 plus 10. Maybe I said, all right, I want to add 27 and 10 first and then add 33. Okay, so 27 plus 10 would give me 37 plus 33. 30 and 30 is 60, 7 and 3 is 10. So that's a total of 70. Notice how in our second step, each time the add-ins are different because I'm using these different properties. Doesn't matter, the answer is the same. So again, if you think this might be something that your students might struggle with, you might start out with just a simple problem like, okay, here we have 3 plus 4. How many do I have if I put them together? I have 7. What if we switched the order? Notice the order is switching and I have 4 plus 3. I still have 7. So order does not matter. So you might consider illustrating that at the start of the lesson if you think that it's going to be a lot for students to comprehend. Now, if you want to touch on this with your students, if you think they're ready for it, okay, but I always like for us to think about, just for us as teachers and educators, to note that there is no associative or commutative property of subtraction, because order does matter when I'm subtracting. These are like those famous problems they throw on Facebook and ask what the answer is. And a lot of people get them wrong because of not following the correct order of operations. So we know that it does matter when we're subtracting. If we look at one like this, 120 minus 20 plus 5, that's not the same as 120 minus 5 plus 20. So Again, we wouldn't get the same answer, just like is 10 minus 8 the same thing as 8 minus 10. This gets into negative numbers. Again, I am absolutely not suggesting at all that you address this with your students. Just maybe if you've got some advanced students that are just that need a little extra challenge, you might ask them, is there an associative property or a commutative property of subtraction? Okay, now it's also important to notice with today's lessons that we're not focusing on actually having them find sums and differences. We're focusing on having them look at how they can rearrange to make finding the sum and difference easier. So they'll have some problems like this one. If you want to look at a more in-depth overview of this, check out the teacher video or the student video. So they'll have some of these where they're applying the commutative property, and then some like this where they're applying the associative property. And again, we're just having them apply the property, not focusing on them actually finding the sum, because that's what we're going to be doing in the next few lessons. All right, my friends. Awesome. Thanks for joining. We'll see you in another lesson.